All right. Another topic that showed up in this first unit is just, in general sense, something called problem solving, which is a clever way of saying I'm going to throw random questions at you and just see how you do. It's not quite true. There's some pattern to the types of questions I'll throw at you. But number 4 here definitely fits in that category. How many different ways can you make change for 25-cent coin using nickels and pennies? So what I'm looking for in this type of question is that you have some form of organized thought, and the key here is organized. You're just not randomly throwing down things on paper and then trying to make something intelligent come out of randomness here. I'm looking for evidence that you actually know how to organize your thinking, because keep in mind, as future teachers, you need to be able to communicate in a way that's effective for your students. Okay. So here's what I would think would make the most sense. I'm going to draw a little chart, and I'm going to label it 5-cent pieces and 1-cent pieces. And off to the side here, I'm going to just remind myself that I'm looking for 25 cents. And then I'm just going to make a list of values that would work. So what's the most number of nickels that I can make 25 cents for? And that would be 5, and there'd be 0 pennies. Okay, so then, and this is where the organized part comes in, if I take 1 nickel away, so if I now have 4 nickels, how many pennies does that demand? That requires 5 pennies. If I take another nickel away, that's another 5 pennies. 2 nickels means I have to have 15 pennies and change. 1 nickel means I have to have 20 pennies. And 0 nickels means I have to have 25 cents. All 25 of them in pennies. Okay. So notice the organization component. And then the question is actually asking how many different ways can I produce this. So I'm going to look at my combinations. I could have 5 0, could have 4 5, 3 10, 2 15. I'm just going to count. I got 6 ways. So that's my answer, is that there are 6 different ways that I can make change. All right, this seems like a rather specific skill to pull out of thin air and expect students to do. But oddly enough, a magic square does demonstrate several skills at once. So it's just a good practice just to throw one at you and go, all right, let's see what you got. All right, so the technique that I'm going to do with this is I need to first figure out what they all add up to. The idea is that I'm going to put 3 numbers in a row, box, diagonal that add up to the same thing. So any 3 numbers should have the same sum. So that'd be nice to know what the sum should be. So let me add up these numbers real quick, and we're going to take that and divide by 3. So 10 plus 11 plus 12, 13, 14, 15, 16, 17, and 18. Okay, so I get 126, and this should be something divisible by 3, and I get 42. Okay, so that means when I start putting combinations of numbers together, I need them all to add up to 42. All right, well, one easy way to do this is, let's just take the smallest one. So 42 minus 10, I'll pull up my calculator here. Sorry, made my calculator go away. All right, so 42 minus 10, and let me start with the biggest number, so minus 18, and let's see if that's a combination. It is. So so one combination I get is 10, 14, and 18. Okay, so let's try that again. Let's try 42, and let's go minus 10, and let's try 17 and see if that's part of the mix. And it is. So 10, 15, and 17. So you can kind of notice we're going up 1 and down 1. So if I do that again, I get 10, 16, 16, but that's not a choice. I don't get to add 16 and 6, because I only have one 16 that I can use. So that's not a valid combination. So those are the only two that will show up with 10. So then let's do an 11. And so 42 minus 11, oops, helps if I type that correctly. All right, so we get 31. And let's try that 18 again. And I get 13. Okay, so that's actually valid. So 10, 11, 13, and 18. And again, if I go to 17, I should get 14. And 15, I should get 16. All of which, and we can stop and double check that. So just 11 plus 15 plus 16. Oh wow, let's try that again. 11 plus 15 plus 16 should give me 42. Yep, okay. And if I keep going again, so if I go up 1, I get 16 and 15? And notice it's the same combination, just in a different order. So there's no sense to keep going anymore here. So then we'll go up to 12. And 12, let's see, can I get 12 and 18? And some other number, so 42 minus 12. And if I take 18 away, notice I get 12, 12, and 18. So 12, 12, and 18 adds up to 42. However, I can only use 12 once, so I can't use 12 and 18. So that's not a combination. But maybe I can use 12 and 17. So 42 minus 12 minus 17. And there we go. So 13 does show up. All right, so 13 and 17. And then I can do the add 1, take away 1 thing. So 12, 14, 16, 12, 15, 15. Okay, notice we got 15, 15. So that's not going to be a valid combination. And let's see, what do we got so far? We have 1, 2, 3, 4, 5, 6, 7. We got 7 different combinations. And I feel pretty confident about this. Is there any number I noticed that shows up more often than anything else? I'm seeing 13, and I see 14 show up a bunch. Let's kind of look at 14 for a second. 14 seems to show up the most. 14 is 1, 2, 3, 4 away, and 1, 2, 3, 4. So 14 seems to be dead center. So that would be where I would want to stick in the middle there. And then I just want to start laying down combinations of things as I see them. And again, we might have to do a little troubleshoot along the way, but I know 10, 14, and 18 have to go together. And 10, 15, and 17, well, the only way 10, 15, and 17 are going to work, if I add that up, and I'm going to just keep track of this, that it's 42 each time. Let's see, 11, 13, 18. Well, I can see 18, so 11 and 13. Now, at that point, I'm not sure if I need to rearrange that, because notice I've got the 17 and 13 on the same row, and the 15 and 11 on the same row, and I don't think, well, we do that combination, so 11, 15, all right, so that would have to be 16. Did I do a 17 one? I didn't, but I could do a little analysis and see what's missing. Let's see, 10, 11, 12. So that's got to be, 12's got to go there. Okay. So before I get all excited and just double and say, oh wow, I think I got them all, let's just double check my combinations and make sure. So we said 11, 15, and 6. So this part was 42. How about 17, 12, and 13? So let's go across there. 17 plus 12. Oops. Helps if I type this right. 17 plus 12 plus 13. and I get 42. Okay, so I know going 42 that way. 16, 14, and 12, that's 42. And let's see, 11 plus 18 plus 13. 42, yay, okay. And is there any other way I could do it that I probably should check? Let's do diagonals. 15, 14, and 13. Didn't show up on my list yet, but plus 14 plus 13. Okay, 42. Okay, might as well check the other diagonal. Why not? Be consistent. I would hate to find a minor error that I didn't necessarily plan on. Okay, so all of that. Okay, so that is the correct answer. Now you may have it sort of in different order, but 14 would be in the middle. You know, if your 16 is down at the bottom, then your 12 would be up top. So your orientation might be different, but the pattern of the numbers would be the exact same. This is another problem-solving question, so something you just have to be creative about how you organize your thoughts. Juan's team entered a math contest where teams of students compete by answering questions that are worth either 3 or 5 points. No partial credit was given. Juan's scores was 44 points on 12 questions. How many 5-point questions did the team answer correctly? Okay, so I know that there were 12 questions. And so I'm going to do a little organization here. I'm going to do a little 5 points and 3 points. And I know that there were 44 points made. So let's start with the highest number of 5 points that I can put in there. Let's see, I could try 8. And that would be 8 times 5 give me 40, but then I wouldn't have enough. So 8's not right. Could try 7. Well, let me keep track of this. Let's try the utter failure. So 8 doesn't work. How about 7? So 7 times 5 is 35. And 44 minus 35 gives me 9. And so there would be 3 questions there that I could answer. Ooh. Okay, but what do you notice? 7 plus 3 does not equal 12. So even though I got a valid combination, I didn't get enough. It's not enough questions. So that does give me 44 points, but it's not quite enough. All right, so let's try 6. 6 would be, let's see, 6 times 5 is 30. Wow. Try that again. 6 times 5 is 30. But 44 minus 30 is 14, and there's no way 3 points can give me that. Let's try 5 questions. So 5. So 5 times 5 is 25. And 44 minus 25 is, what is that? It's 19. Okay, so that's not enough. Let's try 4. So 4 times 5 is 20. Then 44 minus 20 is 24. Aha! So 24 means I have to answer 8 3-question points. And 4 plus 8 is actually 12. Yay! All right, so there's our winning combination. Again, I'm looking. And then the question actually is how many 5-point questions are there? So there are 4 5-point questions. Okay, but what I'm looking for is just organization. Obviously, I'm looking that you can answer the question correctly, but that you can communicate the method in which you went about answering it. So a chart like this, just some work off to the side, but you want to avoid the random sort of, I'm going to write a little bit at the top, a little bit at the bottom, a little bit at the center, and I'm not even sure what's relevant. So anyways, something like that.